When selecting cable tray sections, several factors influence the choice, especially when dealing with directional changes and maintaining parallel runs. For a scenario where a cable tray needs to parallel a platform, execute a 90-degree turn, and then continue to parallel the same platform, a horizontal T-section is typically the most appropriate choice. Firstly, let's define the components and their typical applications. A vertical T-section is designed for situations where a cable tray needs to split vertically, either moving upwards or downwards from the main run. This is commonly used to branch off to different elevations or equipment located above or below the primary cable tray level. A vertical L-section, also known as a vertical elbow, facilitates a 90-degree change in direction in the vertical plane. This means the cable tray will either rise or descend at a 90-degree angle. This is useful when navigating around obstacles or connecting to equipment at different heights. A horizontal L-section, or horizontal elbow, is used to make a 90-degree turn in the horizontal plane. This is suitable when the cable tray needs to change direction on the same level, such as turning a corner in a building. A horizontal T-section is specifically designed to split a cable tray run into two directions on the same horizontal plane. This allows for branching off in two different directions while maintaining the same elevation. Now, considering the scenario described, the requirement is to parallel a platform, make a 90-degree turn, and continue paralleling the platform. The horizontal T-section is the optimal choice for this application. Here's why. The horizontal T allows the cable tray to initially run parallel to the platform. At the point where the 90-degree turn is required, the horizontal T-section is installed. One branch of the T continues the original direction, maintaining the parallel run along the platform. The other branch of the T creates the 90-degree turn, allowing the cable tray to change direction. After the turn, the cable tray continues to run parallel to the platform on the new axis. Using a vertical T or vertical L would be inappropriate because they change the elevation of the cable tray, which is not required in this scenario. A horizontal L could achieve the 90-degree turn, but it would not allow for the continuation of the parallel run in the original direction. Therefore, the horizontal T is the only option that satisfies all the requirements of the scenario. Cable tray systems offer numerous advantages in electrical and data cable management. They provide support and organization, making it easier to install, maintain, and modify cable runs. Cable trays are available in various materials such as steel, aluminum, and fiberglass, each offering different levels of corrosion resistance and load-bearing capacity. The selection of the appropriate cable tray material depends on the environmental conditions and the weight of the cables to be supported. When installing cable trays, it is crucial to follow the National Electrical Code, or NEC, and other relevant standards to ensure safety and compliance. The NEC provides guidelines on cable tray installation, including spacing, support, grounding, and bonding requirements. Proper grounding and bonding are essential to prevent electrical hazards and ensure the integrity of the electrical system. Cable trays must be securely supported to prevent sagging or collapse, especially when carrying heavy cable loads. The spacing between supports depends on the cable tray type, material, and the weight of the cables. Overloading cable trays can lead to structural failure and create safety hazards. It is important to calculate the cable load and select a cable tray system with adequate capacity. Cable trays should be installed in a manner that allows for easy access for maintenance and future modifications. Avoid installing cable trays in locations where they may be subject to physical damage or exposure to corrosive substances. Regular inspections of cable tray systems are necessary to identify any signs of damage, corrosion, or overloading. Any issues identified during inspection should be addressed promptly to prevent potential problems. When adding or modifying cable runs in a cable tray, ensure that the new cables are properly supported and secured. Avoid overcrowding the cable tray, as this can restrict airflow and lead to overheating. Cable ties or other cable management accessories can be used to organize and secure cables within the cable tray. Proper cable management not only improves the appearance of the installation, but also facilitates troubleshooting and maintenance. When working with cable tray systems, always follow safe work practices and wear appropriate personal protective equipment. This includes safety glasses, gloves, and other gear as needed. They energize electrical circuits before working on or near cable trays to prevent electrical shock hazards. Cable tray systems are widely used in industrial, commercial, and institutional facilities to support and manage electrical and data cables. They offer a flexible and cost-effective alternative to conduit systems, especially for large cable runs. Cable trays can be customized to meet specific installation requirements, with various accessories available for turns, splices, and terminations. When designing a cable tray system, consider the future needs of the facility and allow for expansion and modifications. A well-designed cable tray system can provide years of reliable service and contribute to the overall efficiency and safety of the electrical infrastructure. In summary, the horizontal T-section is the correct choice for the described scenario because it allows for a 90-degree turn while maintaining a parallel run to the platform both before and after the turn. Understanding the specific applications of different cable tray sections is crucial for effective cable management and ensuring compliance with electrical codes and standards. Always consult with qualified electrical professionals for cable tray system design and installation. Cable trays are essential components in modern electrical systems, providing a structured and organized way to support and manage cables. Different types of cable trays are available, each designed for specific applications and environments. Ladder cable trays are characterized by their open construction with rungs spaced along the length of the tray. This design allows for excellent ventilation and easy access to cables for maintenance and modifications. Ladder cable trays are typically used for heavy-duty applications where large cable loads need to be supported. Ventilated trough cable trays have a bottom with ventilation holes, providing airflow to prevent cable overheating. The sides of the tray offer support and containment for the cables. Ventilated trough cable trays are suitable for medium-duty applications where some ventilation is required. Solid bottom cable trays have a continuous bottom surface, providing maximum cable support and protection. This type of cable tray is often used in environments where cables need to be shielded from dust, moisture, or other contaminants. Wire mesh cable trays, also known as basket trays, are made of welded wire mesh, offering a lightweight and flexible solution for cable management. Wire mesh cable trays are easy to install and can be cut and bent to fit specific installation requirements. Single rail cable trays consist of a single support rail with cable clumps or hangers attached to it. This type of cable tray is suitable for light-duty applications where only a few cables need to be supported. The choice of cable tray type depends on factors such as cable load, environmental conditions, installation requirements, and budget. When selecting a cable tray system, it is important to consider the total weight of the cables to be supported, including any future additions. The cable tray should be sized to accommodate the cable load with a safety factor to prevent overloading. Environmental conditions such as temperature, humidity, and exposure to corrosive substances can affect the lifespan and performance of cable trays. Select a cable tray material that is resistant to the specific environmental conditions in the installation location. Installation requirements such as the need for turns, splices, and terminations can influence the choice of cable tray accessories. A wide range of accessories is available to facilitate different installation configurations. Budget constraints may also play a role in the selection of a cable tray system. Consider the total cost of the cable tray, including installation and maintenance, when making a decision. Cable tray systems must be installed in accordance with the NEC and other relevant standards. The NEC provides guidelines on cable tray spacing, support, grounding, and bonding requirements. Proper grounding and bonding are essential to prevent electrical hazards and ensure the integrity of the electrical system. Cable trays should be supported at intervals that prevent sagging or excessive deflection. The support spacing depends on the cable tray type, material, and cable load. Cable trays should be securely fastened to the building structure using appropriate hardware. Avoid installing cable trays in locations where they may be subject to physical damage or interference from other equipment. Regularly inspect cable tray systems to identify any signs of damage, corrosion, or overloading. Replace or repair any damaged components to prevent potential problems. Keep cable trays clean and free of debris to ensure proper ventilation and prevent cable overheating. When adding or modifying cable runs in a cable tray, ensure that the new cables are properly supported and secured. Do not exceed the cable tray's load capacity. Cable tray systems are an essential part of modern electrical infrastructure, providing a safe and efficient way to support and manage cables. By understanding the different types of cable trays and their applications, you can select the appropriate system for your specific needs. Always follow the NEC and other relevant standards when installing and maintaining cable tray systems to ensure safety and compliance. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician for any electrical project. Cable tray systems are often used in conjunction with other cable management products, such as cable ties, clamps, and labels. Cable ties can be used to bundle and secure cables within the cable tray, preventing them from becoming tangled or damaged. Clamps can be used to secure cables to the cable tray, providing additional support and preventing them from moving or vibrating. Labels can be used to identify cables within the cable tray, making it easier to troubleshoot and maintain the system. Effective cable management is essential for maintaining a safe and reliable electrical system. By using cable trays and other cable management products, you can keep your cables organized, protected, and easily accessible. This will not only improve the appearance of your installation, but also make it easier to troubleshoot and maintain the system over time. In conclusion, the horizontal T-section is the most suitable choice for the scenario described, enabling a 90-degree turn while maintaining a parallel run to the platform both before and after the turn. Thorough understanding of cable tray types, installation practices, and relevant codes is essential for ensuring a safe and efficient electrical system.